And now I'll announce our next speaker, Jason. So thank you so much, Jason, for coming.
Awesome, thanks, Matt. And thanks for joining. My name is Jason Cow. I'm the head of security research at CloudQuery. And this talk is titled, Why'd you have to go and make things so complicated? Navigating identity and access management multi-account cloud estates. And yes, that is an Avril Lavigne reference. So today, we're going to talk about mostly multi-accounts. Specifically, to give a background, cloud adoption trends. We'll then go into introduction of what multiple accounts are, including what an account may be or what it looks like, as well as multi-account architectures. Then we'll talk about identity and access management risks, including single account risks and also multi-account risks, and how single account risks may also apply to multiple accounts. And finally, we'll wrap up with managing IAM at scale across multi-account cloud estates, including IAM best practices, infrastructure design, and architecture best practices, and lastly, how to monitor these and maintaining what we call a chain of identity. So let's talk about cloud adoption trends and how we scale cloud for the enterprise. This chart is from AWS, so it may be a little bit biased about cloud adoption, but what we have here is when we first think about a project and bring it to the cloud, we think about building what we call a cloud foundation. Then there's migration, reinvention, where more cloud-native services, such as Azure Cosmos, for example, AWS SageMaker for data scientists, Google BigQuery, right? All these require a foundational platform in cloud. For example, if we look in EC2 instance, that actually requires about 14 different resources, which include an account, a VPC, subnets, security groups, availability zones to make sure, right? Possibly an internet gateway if you're using IPv4, et cetera, et cetera. It also may use IAM, such as instance profile, managed policies, and the list goes on. If we're looking at something like an S3 bucket, right, that's a little bit simpler, but we still need an IAM role, we still need, or IAM principal, I should say. We'll also need an account in general. And these accounts form the foundation of what our cloud may look like. So we've talked about accounts, let's talk about multi-account usage. In a study done by Orca Cloud Security in 2023 in March, they found that there's a lot of usage of multiple accounts. 63% of AWS users have multiple accounts, and this is not a typo. 63% of Azure users as well have multiple accounts, and 65% of Google Cloud users have multiple accounts. And this number is growing. As cloud adoption grows, the usage of multi-account architecture grows as well. So we've now spent the last couple minutes talking about accounts. So what are accounts in general? And they're a new concept in cloud that forms the foundation or the infrastructure for what we're building. Here's a little bit of account terminology. We have GCP on the left, AWS in the middle, and Azure on the right. GCP we'll start with the base level of resources, right? And we'll do this with all of these, right? Resources are the foundational building blocks. For example, an S3 bucket in AWS, Azure Blob for storage in Azure, different databases, et cetera, virtual machines, what have you. In GCP, these look like resources at the very bottom. Those are contained by projects, then folders, then organization, which is probably what a lot of organizations or companies may have. In AWS, it starts with resources. It goes up to accounts. It goes up to then organizational units, which are groupings of accounts, and then organizations, which are groupings of OUs or accounts or both. In Azure, we have resources, then resource groups, then subscriptions, which is their terminology for an account, and then management groups there as well. So that being said, let's look at the definition, and a lot of these are actually pulled from cloud providers themselves, maybe doctored a little bit to make sure they fit on this page. So we have our accounts. In AWS, it's a basic container for all the AWS resources you create as an AWS customer. In Azure, a subscription logically associates user accounts with the resource that they create. And then Google Cloud projects form the basis for creating, enabling, and using all Google Cloud services, including managing APIs, enabling billing, adding and removing collaborators, and managing permissions for Google Cloud resources. So what's our definition? Our definition is an account is a logical boundary or a container used to contain resources. This logical boundary can be leveraged as a security boundary. So now that we have those definitions out of the way and we understand a little bit more about accounts, let's talk about the evolution of account structure and how does our cloud infrastructure architecture look across the board. This is a page from AWS. It's a reference multi-account architecture. It's a little bit small to see, but what you can see here is we have our root, which is an organization. We have management, which is the management account. We'll talk about that a little bit later. We have a security OU. Within that, there's a prod OU that's nested. There's a sandbox OU. There's a workloads OU with prod, test, dev. but this is just a reference multi-account architecture that AWS has. In this picture, there's probably a little bit over 10 accounts. I didn't do the math. I think 11, 12 maybe, just from a quick glance. But this is the foundation of how we can organize our accounts and how multi-account architecture may work. For some organizations, or some companies that use AWS, it can look like an AWS account per team. Multiple teams can share an account. Differences depending on what your footprint may look like. So this brings us to this slide, and I referenced this earlier. Not all accounts are the same. It's generally a dichotomy, but there's a new concept that makes it a little bit more tricky, at least now. And there's the concept of a management account. This account is an account that is used to create the organization. The account specifically has certain privileges that can affect member accounts. So it's almost like a super account. And then all other accounts are considered member accounts, which are non-management accounts in the organization. And these can only belong to one organization at a time. And then lastly, the complexity of this is there are now delegated administrator accounts, which are what they sound like, where they are member accounts that can be designated as delegated administrators to administer and manage tasks in AWS service that may span across accounts and integrate with organizations. For example, they can administer guard duty, they can administer logging, they can administer other security services like firewall manager, et cetera, backup if they want. But there's a lot of usage for using delegated administrator accounts, and as cloud grows and as time goes on, AWS has actually introduced more and more support for delegated administrator accounts as well as what they can do. So now let's talk about IAM risks and IAM attack paths. We're going to start with single account risks, and some of these you may be familiar with, so I won't spend too much time on this page. But we'll have attacks such as privilege escalation, the common ones such as IAM create user that allows us to create an IAM user that possibly has access keys, creating access keys is a different command, attaching role policy, which allows us to attach a policy to a role that may grant it permissions itself, IAM pass role, which is another, there's a lot of research on IAM pass role actually, that shows how to, this can be used to allow services to use a role, such as Lambda. So when we first create a Lambda function, passing a Lambda execution role to Lambda function, that requires IAM pass role. There's also STS assume role, which allows us to assume a different role, and that we'll go into that a little bit more later. These are all risks to escalate privileges, look at sensitive data, right? Possibly do more in the account itself. We also have data exfiltration risks, such as S3 access, a couple different mechanisms of S3 access, including IAM, including S3 bucket policies or resource-based policies. Also KMS decrypt, if that gives us access to a KMS key that's used to encrypt our data across the board. There's also misconfigured trust, which relates to IAM roles, and also confused deputy problems. This is a newer attack or risk that we've seen. And also, over the last couple of years, AWS has done a lot of additions or how to help prevent against confused deputy problems. And this is when a service is tricked into behaving on behalf of an attacker as a confused deputy. So you'll see this in the trust relationship, right? If the trust relationship of a role trusts a service, this can be used to use that service improperly. This is meant to look complex because it is. This is a diagram from AWS on IAM permission models. We won't spend too much time on the slide either, but just to show you, right, we have a principal, authorization, actions, resources, the request itself, and different accounts on the right, and how these are evaluated. The next slide also details how complex IAM is in AWS. This is a newer slide that they came up with, or a newer diagram, that really shows us how policies are evaluated in AWS. If you're familiar with AWS, it used to look like three things. Explicit denies, evaluate first, then explicit allows, evaluate, then implicit denies. In this, right, there are now multiple different types of policies, including organization SCPs, resource-based policies. We talked about S3 bucket policies earlier, that's an example. SQSQ policies, SNS topic policies. Even if we think about the role trust for an IAM role, that's considered a resource-based policy. KMS key policies as well are also resource-based policies. Another complexity is that resource-based policies may behave differently depending on what it is. We're not going to cover that in the talk today, but if you look at a KMS key policy, that is one of the only policies that has to be explicitly granted in the KMS key policy for it to work. Most other ones are, ORs. And if you want, we can talk about that later. There's also identity-based policies and IAM permission boundaries. There's also session policies that aren't in this, well, they're on the far right of the screen, but these are all different policies that evaluate together for a policy evaluation logic, and you can see with this, right, if the final decision is allow for the request or if it's a deny. Now, the point of showing this slide as well is that this is also how policies evaluate within a single account. Within two accounts or multiple accounts, it gets a little bit more different. And what we have here, this diagram looks a little bit simpler, but it's based off here as well. The policies and the requests are evaluated separately within each account. So it's evaluated within the trusted account, which is A, and the trusting account B. And then we decide if the final decision is allow or deny. So now let's talk about multi-account IAM risks and new IAM attack paths with multiple accounts. The first couple examples we'll show some of the risks that came up earlier from single accounts. Some of them may be combined. And we'll talk about new risks that come with using multiple accounts within an organization. So the first one is a very straightforward one, resource-based policy. The common example is S3 bucket. So in this example, we have an AWS account A with an IAM role and possible IAM permissions. In AWS account B, we have an S3 bucket with an S3 bucket policy. Based off the bucket policy, based off the IAM permissions for the IAM role in A, right, the IAM role in A can access the S3 bucket in account B. So if we think about how this may be set up in a company, the S3 bucket may allow permissions across multiple accounts. They may allow account routes. They may try to do a little bit more creative things to make sure that people do have access. For example, if it's a central data lake, if it's a shared S3 bucket, right? These are all different examples or scenarios where this may occur. So let's take it one step further. What about multi-account IAM specifically? And here's another risk that can also apply to S3, but more specifically can apply to other resources within the account itself. In this example, an IAM role in AWS account A will jump or assume the role in AWS account B, which then will access a DynamoDB table in account B. And the reason why we use DynamoDB for this example is because DynamoDB is one resource specifically where the only access can come from within that account itself. And the reason for this is there's no resource-based policy, and DynamoDB is based off IAM access itself. Now we have lateral movement. This came up, lateral movement came up yesterday in the keynote from Kevin Mandia. We have lateral movement here across accounts, and we'll talk a little bit more about how this can get worse. So in this simple example, we have lateral movement across accounts from A to B. I can go from, let's say, maybe a non-sensitive account A, and then assume a role in account B. And this gets more complicated when we can do it across environments. With some of the examples earlier, or some of the diagrams earlier, we may split accounts by environment. We may have a development account, we may have a production account. And we've seen this before where an IAM role with broader IAM permissions development may assume a role in a production account. An IAM role with IAM permissions that may then have access to production data. This could be something where someone may have misconfigured their deployment pipelines, may have not put the right input in for deploying, or kept something similar to dev. And they may not know, but this, again, right, in this example, what we see is that in production, there may be stricter controls for access, right? You know, it might be time, it might be firewall, it might be a limited amount of people. But then with this misconfiguration, someone in development or more people in development can then access that data in production. The next one we're going to talk about is principal chaining. This is one of my favorites, specifically role chaining. The diagram here is specifically only for CLI or API only. Another small difference in AWS that you may be aware of is that when we try to chain roles in AWS, we can only jump once. And that's through the console. It's something called switch role. And to truly chain across multiple, we have to do it in the CLI or API and use those tokens. So I can jump from AWS account A, I can jump into AWS account B, then to C, right? And within C, I can even jump around within there as well. Keep this one in mind because we'll talk about this as we go into organizational design, specifically management accounts. There are some nuances about how organizations are created and accounts are created that make this a more devastating attack. Another one is muddied boundaries. This is another one of my favorites for resource sharing, and that's with a service called Resource Access Manager in AWS. If you haven't heard about this service before, this is a service that allows us to share resources, as by the name. And one of those services actually includes a VPC for networking, specifically subnets. The good thing about resource sharing, Resource Access Manager, is that some resources being shared can only be shared with accounts within your organization and not accounts outside. And VPCs are one of those. There are also shared VPCs in other cloud providers such as GCP. But for this one, we'll talk about AWS. And what happens is if I share, and we've seen this one as well, we'll share a subnet from, let's say, a dev account to a production account. And in that case, someone may accidentally deploy production data into the dev VPC that's now shared with the production account. And that's something we don't want. The next attack is reconnaissance. Kevin Mandia also yesterday talked about defenders knowing the accounts better or knowing the environments better. And here's an example of account enumeration. So imagine a company may have 100 different AWS accounts for sake of numbers. And within those, right, maybe 5 of those are very sensitive, 5 of those may be platform security accounts, 1 of them is organizational management account. But if I jump into an account as an attacker, I may not know all these account numbers. I may not know what's going on in there. And depending if an account has these permissions, specifically if it's a delegated administrator or has those organization permissions itself, I can actually call list accounts and grab a little bit more information about what this organization may look like. And here's an example. The top one is if I don't have access, I won't be able to see the accounts. The second one is if I have access to this API called list accounts, then I can see every single account. I can see the ARNs, I can see the emails, I can see the name of the accounts, and a lot of times the names of the accounts may be tied to actually what they are, as well as other information about it. Another interesting fact about this is we look at the join method, invited and created. Created accounts in AWS come with a role called organizational account access role. Invited accounts do not, and this role actually has admin privileges, and we'll talk about it later, and is another good jumping point to jump from account to account within the organization. The next couple slides will focus on something called AWS Identity Center, which is AWS's version of SSO. They've since renamed it a couple times. I believe it used to be called SSO, and now it's called Identity Center. But this is how they access, or this is AWS' preferred method to give access out to, let's say, a group of users or applications across many different accounts. In this diagram here, we have a delegated admin account where I can configure Identity Center and do that access across multiple different accounts. If it's not configured via Identity Center, then basically with every single account, I have to go set up the base infrastructure for, let's say, assuming a role or assume a role with SAML in every single account. This is the way to configure across multiple. A couple key concepts with this, and this is a little bit confusing based on terminology, is they're tied to permission sets, and those are basically given account assignments across the board. And then from those, right, we can add users specifically to those, and it'll give them access to Identity Center, and then also those accounts. That becomes important because in the next 3 slides, we're going to cover 6 different new methods of privilege escalation, and I'll share a resource later of some of the research that we've done on SSO and Identity Center. The first one, we talked about permission sets. Permission set modification is how this is applied. And this action or API call is SSO provision permission set. So if you see this, the permissions most likely have changed somewhere and for someone. There's also adding permissions, and you may notice that some of these are not specifically add permissions, because if we detach or delete deny permissions, that also gives us more permissions or allows us to escalate our privilege. So we have SSO attach manage policy to permission set, attach customer managed policy reference to permission set, and the reason for this is another nuance in AWS, is attaching a managed policy to permission set is attaching an AWS managed policy. Attaching customer managed policy is exactly how it sounds. Attaching customer managed policy, and this is slightly different from IAM actions where we attach the same, where we attach just one managed policy. There's also put inline policy to permission set. If you're familiar with inline policies that are part of that permission set itself, then we can detach managed policy, detach customer managed policy, delete inline policy, and lastly, delete permission boundary from permission set. The permission boundary is another advanced topic from AWS, and that basically, if we delete it, right, that should give us broader permissions because that's used as a boundary to contain the permissions we actually have in AWS. The next 2 are scope change via account assignment, including SSO, create account assignment. And this basically takes that permission set and says, okay, I want to make an assignment to another additional account. If I have access to 5 accounts, I can then add maybe 1, 2, 3 extras. And then also membership modification, right? So with that group itself, I can create group membership and add myself to it. SSO directory, add member to group is another API call that allows me to do exactly the same thing. And the last part is disruption, which is permission modification, which SSO put permission boundary permission set, which gives us like this almost glass boundary around it. And also any permissions from adding permissions themselves. So if I attach a managed policy that's a full deny, I can disrupt permissions there. Access disruption, which is SSO delete permission set, and SSO delete account assignment. The reason why disruption is important is I think back, and actually this was on the news I think in the last week. For example, Clorox, they had a security incident and they had a lot of disruption, right? These types of disruption attacks can actually render an organization fairly incapable to do anything that they want to do after. For example, IR, incident response, even trying to triage things, right? By disrupting this, and the example I would give is if we have a set of administrators that need access to fix an application, by cutting off access, right, or taking off SSO, or taking off, in this case, Identity Center, they may not have access to do what they need to do. So we've talked about IAM risks, specifically across multiple accounts and also single accounts. The next thing we'll talk about is how to manage this effectively at scale. and secure multi-account best practices. In this area, we'll cover, or in this part of the presentation, we'll cover 3 different areas. Take a break real quick. We'll cover identity and access management best practices, infrastructure design and architecture best practices, and lastly, how to monitor for this, and specifically chain of identity. So IAM, these are fairly standard principles. In this case, we're going to look at reducing blast radius, eliminate and reduce role chaining, setting boundaries to reduce overprivilege, least privilege, and also reducing unnecessary access. This is an example of how we can reduce or practice some of these principles. On the left, we have not so great assume role. And in this trust policy, we have ARN AWS IAM account number root. This implicitly allows anything within the account itself to assume this role. It's not the root tied to the account that you get when you create an account with an email and password, but this is actually implicitly any principal within that account itself. On the right side, we then reduce and say, okay, I'm going to allow my first role only. And by doing that, we scope it down so that only my first role can assume into this role specifically. Another example is by IAM permissions, and keep in mind this is slightly different. I'm going to go backwards real quick. In this case, the scoping is done on the principal itself. On the next slide, the scoping is done on the resource block of this IAM policy. And this is a managed policy we've created for the IAM permissions. On the left, we have the effect for allowing STS assume role, and on the right, we have basically only allowing assume role into one specific role itself. And these are all practices of least privilege, or also reducing the trust policy that help reduce the risk of role chaining or improper role assumption. This graph is from AWS, talking about IAM boundaries. We talked about this a little bit earlier. But one of the things we can do in IAM is using organization SCPs, permission boundaries, and things like that. Session policies as well, but those are a little bit trickier. And use these to reduce the effective permissions someone may have. An example is using organizational SCP to block access to assume role to possibly sensitive roles, or using a permission boundary that any dev-created role may have. And by looking at this intersection between the organizational SCP, permission boundary, and identity-based policy, we have the effective permissions there. So next, we'll talk about infrastructure design and architecture. This becomes a little bit trickier because changing accounts or moving resources within accounts is very difficult, especially if they're already production workloads. So we'll talk about AWS organizations and multiple accounts. We'll talk about how to reduce usage of the management account specifically, and here are some nuances there. We talked about created member accounts and not invited ones. They come with this organizational account access role, which is an admin role with ** permissions. And also, another important note is that SCPs do not apply to the management account. And that makes the management account even worse, right? If I can get in the management account, no SCPs apply there. We also recommend leveraging delegated administrator accounts and reducing direct access to any delegated admin and management account specifically. One of the things about AWS organizations, if you're not using it, it can be used for billing, which is the base use case, but additionally, it can be used for creating member accounts. There are other tools out there outside of what AWS provides that allow us to basically add accounts, create accounts on the fly, and then also make sure that these have the proper security controls applied to them. For example, you may want to configure CloudTrail. You may want to remove the default VPCs, but think of these almost as recipes for the accounts to stamp them out from a factory. In organizations, right, we can apply policies. We talked about SCPs or service control policies. Also, we can enable AWS services. And another thing is looking at enabling regions as well. So let's talk about management accounts and account structure. With this, right, here's an example where we have an organizational root and we have the management account there. We can then nest OUs, and we can have an OU here that have the member accounts as well as separate ones, right? And this is where the SCPs do apply, is that policies apply at the root apply to everything within the organization. Policies apply to the OUs or apply to everything below that. And we can also apply SCPs directly to accounts. And we can think of that as if we want to quarantine an account, for example, they may apply a different SCP, or if an account is no longer being used, we may want to cut things off there as well. So let's talk about Delegated Administrator. This is an example AWS organization. What some people do, or what is recommended, is by splitting up tasks within the accounts themselves. So if there's a security task for guard duty, for example, or firewall manager, we can split that up into a security delegated admin. If there's logging or a central logging place that we want to centralize our logs in, for example, we can centralize CloudTrail logs in an organization, we may put that in a logging delegated admin account. We may also have a platform delegated admin account where they may do more DevOps-y tasks. They may enforce backup across the organization, et cetera, things like that. And then we have the organizational management account. By doing something like this, we can reduce the usage of the organization management account, because before, a lot of tasks required the organization management account. And it's highly recommended to move out of there as soon as possible and use it only for break glass access or for only things that require the organization management account. Not in here is another way of delegating administration, which is there's an actual, I think there's a resource-based policy for accounts as well, and that's a different way of delegating administration. It's a little bit different because some of these are API calls, and we'll go into that on CloudTrail. And then we can use these to basically apply and manage our member accounts there. Another example is to do separation across environments. This is highly recommended. Then we can use a production OU, a QA OU, or dev OU, even a sandbox OU. And with this, right, we can apply different SCPs or permissions, et cetera, or like different security guardrails to these accounts. And the reason for this is because our development environments may be a little bit more permissive, but we do want to separate this out. Another benefit of this is in AWS there are some condition keys based off organizations and OUs. And by using very clear OUs and delineation, we can actually use those condition keys to protect accidental lateral movement to other accounts. An example of an SCP, or actually this is just a policy, but you can use an SCP if you want, is we talked about Identity Center, and it's a fairly long list, but this is a SCP that, or a policy that denies all actions that could do privilege escalation with Identity Center. If using this, I'd recommend making sure that we only apply this to non-administrators, because someone still may have to administer Identity Center there. And the last piece is how to monitor, specifically maintaining chain of access. There are a couple different ways to maintain a chain of access within the cloud environment, but we recommend linking cross-account sessions together. There's one way of doing this via tagging sessions that we'll show. We also recommend monitoring Identity Center changes and also account and organization changes across the board. These can indicate some potential compromise. It can also indicate some of these attacks that we talked about so far. So I really like this. This is a feature by AWS that's I think a little bit less used, but they have something called a transitive session tag. And when we tag them, they sound exactly how it is. The example on the right with the STS assume roll call, and then also the trust policy on the left that allows us to actually use transitive tag keys. But this tag, or these tags will persist for every session I jump to. If we just use normal tag keys, it's only going to persist to the first session. But from this, right, let's say I do that role chaining attack, every single session created from that will have these transitive tag keys, and then I can use those tags to link this together. There are other ways to link this as well. If you have access to CloudTrail, you don't necessarily need to use transitive session tags, but I think this is an easy way and something that's easy to look for as well within the logs. We'll talk about monitoring in CloudTrail here. Specifically talked about using delegated administrator accounts or how they're created. Here are a couple examples for, let's say, security services. So we have Inspector, Macy, Guard Duty, and Firewall Manager, which is FMS. So you can see here they're slightly different. They're not all the same. And we have actions such as enable AWS service access, register delegated admin, enable delegated admin account, enable organizational admin account, and associate admin account. They're all slightly different. Some of our research covers the differences there, but they basically all do the same thing, where it's harder to track because they all have different names and different keywords, but they all do the same of allowing a service to delegate within a member account. And the key thing for this too is every time we see this and we see a registered delegated admin account, that actually gives the account access to list accounts, see other details that's implicitly needed for that service to function. So in conclusion, we're not trying to scare you away from using multiple accounts. It truly does help and add security boundaries, specifically within AWS and other cloud providers. I would say multiple accounts is the way, but to ensure that we do security best practices and we recommend reducing the possibility of risky account IAM combinations, such as the ones we talked about. We also recommend maintaining and managing account infrastructure design. This gets a little bit trickier, as mentioned, because moving accounts or switching accounts is typically somewhat tricky and may not be as feasible with production environments or already deployed to production workloads. And we also recommend, listening to Kevin Mandy yesterday, he mentioned protect what matters most. And in this case, right, our account infrastructure, or specifically our delegated administrator accounts, and also our organizational management account is what matters. And lastly, we recommend monitoring for any of these changes and maintaining chain of access. Thanks for your time, and I appreciate you all listening to me. We do have some time for questions, Matt, if anyone would like to ask questions. Yes.
So you were speaking about AWS. Did you have any chance to compare multi-account issues with other clouds like Azure?
Yeah, and that's a good question. I think the AWS IAM model and the account structure is slightly different from Azure and GCP, so some of those risks will inherently be different. Personally, I haven't done as much research on like different cloud providers. My background is primarily AWS, but I believe there are decent resources out there to cover those as well.
So you mentioned there are issues with a already in production environment and trying to, establish these policies. Do you have a strategy for that challenging goal or direction?
It's a good question. I think what I've seen is, I think a little bit more effective is when applying new policies, specifically IAM across already existing infrastructure. It typically looks like a lot of trial and error and working closely with dev teams, which is not a great answer, but ensuring that we don't cut things off. Actually, recently, AWS released a little bit more support for IAM last access across different services. I think that does help as well. But again, it's a lot of trial and error, looking at CloudTrail to make sure things aren't blocked, testing in QA. As for looking at organizations account management, I think what I would recommend, and this is a personal opinion, is start slowly moving things to delegated administrator accounts, because creating accounts is easier than converting already existing ones, and there may be a lot of legacy things in those accounts themselves, right? So if you can imagine the organization management account prior to a lot of this has a lot of access, right? A lot of teams have access to it, but even just monitoring that and then slowly moving some of those out, like management of, let's say, guard duty, right? Move that out, managing of backup, managing of central logging, because it may not just be the security team that needs access to that. It may also be like a forensics teams, it may be like DevOps teams, but slowly doing that and ensuring that the access isn't cut off, I think is most likely the best way. And then a little bit of redundancy goes a long way, ensuring that it's available in one, may cost a little bit more, but ensuring that it's fully available in the other or new environment before it's shut off.
I wanted to ask if you had any best practices in terms of role scoping, because a lot of times when you're working on an engineering project, the documentation, we say you need the organization level role when you don't necessarily need it. Is that kind of going to be a guess and check method, trial and error, or?
Yeah, so I think there are certain tools out there, including some companies that do this, where they help craft IAM policies based off what has been done or what they may think are the permissions needed. I haven't tested those fully to see how effective they are, but one of the things that we've seen from like a DevOps perspective is typically in lower environments, the permissions are a little bit more or broad. So let's say like in dev or even a sandbox, right, they may be a little broader there. And then as we move up the chain to higher environments, then we can see, hey, what does the credential report look like? And not the IAM credential report, but like what is being accessed, and then scope those down. And in QA, right, that's where the testing really comes into play. I think generally from what I've seen in practice, it's really hard to adjust permissions that have already been deployed, because I think there's always the fear or the worry that something may get cut off. But for net new, right, I think it's ensuring that throughout the development practice that IAM across your organization is easy to manage. And I think that's probably, thinking back to it and answering your question now, I think one of the best things is ensuring that IAM management is really easy to experiment with, and that feedback loop is shortened, right? So some organizations may have like a central place to deploy IAM, or like it has to go through a specific team. That feedback loop is really hard for developers. They may not want to go back multiple times, or if they have to interact with a separate API, that's really tough. But if they can experiment in AWS, use the console if they need, use the APIs directly, and modify their IAM roles and permissions, then I think that's a lot more useful and helps them, or in your case, right, helps that principle of least privilege, right? But it's, I think it's always an evolving target. Examples could include like it needs access now, it may not need access later, but changing requirements as well. I think it's a hard battle. We're good. Thanks, everyone.